The topic is electrochemistry. Electro word related to electricity, electricity related to electrons. So when we talk about the subject electrochemistry, we have to apply two different ideas. First is how to use electricity for chemical reactions. Second, how to use chemical reactions to generate electricity. So there are two different ideas. Of course, in both the cases, certain common principles of fundamental physics will be used. We are going to study the DC electricity part in the entire subject. So don't have the wrong idea. AC, alternating current, is not involved anywhere. What we are doing is related to DC electricity, direct current supply. So we'll be having the basic ideas. V equal to IR, Ohm's law applicable. Current will be there, resistance in the circuit, V potential difference. We also know electrical energy. Electrical energy is VIT or I square RT. Both these ideas are related to electron flow. What is after all electricity? Flow of electron. But when we talk about the electron flow in chemistry, it is related with a very fundamental reaction called redox reaction. So let us have some discussion about redox reaction. Redox reaction is related with the exchange of electrons. At a time there are two reactions happening. One is called reduction, other is called oxidation. Reduction means gain of electrons and oxidation means loss of electrons. So reduction, gain of electrons, and oxidation, loss of electron. So when there is a gain of electron here, definitely the oxidation number will definitely decrease, whereas in oxidation process, oxidation number will increase. Oxidation number is a relative charge on a single atom involved in a molecule or radical. So reduction happening with a gain of electron, oxidation happening with a loss of electron. This process is called redox reaction, which can be spontaneous or non-spontaneous. So when it is a spontaneous redox, spontaneous is effortless process. It is a spontaneous redox in electrochemical cell reactions, and when it is a non-spontaneous reaction, it is in electrolysis. So somewhat different topic of chemistry, having a background of physics. Electrical energy required, DC supply required. V equal to IR is applicable, Ohm's law. Electrical energy, VIT. Electron flow is related with the redox reaction. Certainly, other concepts of electricity circuits like resistances in series, resistances in parallel are also having some role in this topic. When the resistances are in series, you know the total resistance is the addition of individual resistance, and here the reciprocal addition equal to 1 by R, where R is the net resistance of the circuit. Here the net resistance will go down. Here the net resistance will increase in the series circuit. Same ideas are applicable in this topic also. So when we talk about electrolysis, lysis means breaking. Electrolysis is a reaction where you get a chemical reaction at two different places. One is anode, other is cathode. Electrochemical cell is also related with two different electrode reactions. One is anode, other is cathode. And here the question should come in your mind, what is this anode and what is this cathode? Anode is the electrode, it is the electrode system having always oxidation. Anodic oxidation is the terminology. Cathode is the electrode where there is always reduction. So whether it is a electrolysis or whether it is an electrochemical cell, the reaction at anode is always oxidation. Oxidation means loss of electrons. Reaction at cathode is always reduction, and reduction means gain of electrons. Both these reactions are happening simultaneously at two different electrodes involved in the system. One is called electrolytic cell, other is called electrochemical cell. In electrolytic cell, electrolysis is carried out by using electrical energy to get chemical products, that is chemical reaction. In electrochemical cell, there is a spontaneous redox reaction which will generate electricity called EMF, electromotive force, in DC volts. So electrochemical cell is just like the cell which you are using for your mobile, that is actually called battery. Battery means many cells in series, like car battery, like dry cells. They are commercial cells which we are using in our day-to-day life. They are all electrochemical cells. But electrochemical cell means something which is called spontaneous redox reaction. And electrolysis is a non-spontaneous redox reaction. Both the things are related with a common system, and that is what called electrolyte. So electrolyte is our need. Electrolyte will be acids, bases and salts. They are dissociated into ions. When we take solution like aqueous solution, it will have some concentration. Anode is the electrode where there is an oxidation reaction, loss of electron. Cathode is the electrode where there is a reduction reaction, gain of electron. And the subject is of redox reaction at a time happening at two different places in a cell, which may be electrolytic cell or electrochemical cell. So let us concentrate on the concept of electrode. When we talk about electrode, electrode is not simply metal. Don't have this idea that one metal taken as electrode. It is called conductor. So when you take a metal, it's a conductor. But when the metal is surrounded by a solution containing ions, that represents electrode system. Like that, we can have several electrode systems. Now, electrode systems called single electrodes. Single electrodes are many. Metals are there, surrounded by metal ions. Gases are there, surrounded by gaseous ions. Sparingly soluble salt electrodes. And finally, redox concept, two different ions coming together, making an electrode called redox electrode, and they are the simple electrodes available. Any combination is possible. Single electrodes are also having another word, half cell. Now, the question comes here, what they do? They have a potential to react with each other. So, if you take a metal, it will form metal ion with a loss of electron. The process called oxidation, and the reverse process is called reduction. Metal ions will make metal. Now, some metals or some electrodes can easily donate the electrons, and they have a potential positive for the reaction called oxidation. Some reactions where oxidation is difficult, reduction is easy and comfortable, they will have a positive values of reduction potential, and they have a tendency to go for reduction. So it is represented by the term E, electrode potential, not for standard condition, and this will be equal to standard reduction potential at 25 degrees centigrade, 1 atmospheric pressure, 1 molar concentration of the solution, and this is actually listed in the form of a big table or a chart or a collection called EMF series. This series is available in every chemistry textbook as a data. EMF series. What they have? In EMF series, you have a big list of electrode system. Some of them are easily oxidized. Some of them are easily reduced. and the values are available accordingly in volts at standard condition. Standard reduction potential is only electrode potential according to international standard. So when we use the word electrode potential according to international standard, it is standard reduction potential at this condition. If it is positive, there will be easy reduction spontaneously happening. If it is negative, there is a easy oxidation spontaneously happening, because E of oxidation equal to minus E naught of reduction. So the electrodes which are showing positive value of reduction potential are definitely having no interest for oxidation. Electrodes having negative value of reduction potential are mainly having interest for oxidation. And what is after oxidation? Loss of electron, and reduction, gain of electron. E oxidation, standard condition, minus E oxidation, reduction condition. The data given in the form of table or chart called EMF series, activity series, or electrode potential series. This is available at standard condition. It is a guideline for us to understand the electrode which we have selected, whether it will go for reduction or it will go for oxidation in a reaction. If it is electrolysis, again I repeat, the process is non-spontaneous, and when it is an electrochemical cell, the process is spontaneous. Spontaneous process means thermodynamically we can say that the value of delta G called Gibbs free energy, and this delta G value will be equal to minus NFE. We'll put E naught, delta G naught. Standard free energy change minus NFE. This N for moles of electrons, number of moles of electrons. F for now 1 Faraday electricity, which is 96500 coulombs. And here one important part which you have to understand, 1 mole of electron, not 1 electron, 1 mole of electron is nothing but 96500 coulombic charge. 1 mole of electron, 96500 coulombic charge. E naught is the EMF concept, electrode potential, and that is related with the thermodynamic term delta G. When this will be positive, this will come negative. When delta G negative, thermodynamically we say process is spontaneous. When this is negative, this term will come positive. Delta G positive means thermodynamically say the process is non-spontaneous. Since we apply electricity to carry out the reaction, we have delta G value. We apply the energy. Delta G value is definitely greater than 0, and the process is non-spontaneous. When we get EMF or electrode potential concept, delta G will come negative, and in that case the process is spontaneous. So one should understand the main difference, and also one should say anode and cathode properly. Anode is the one where there is oxidation, and cathode is the one where there is a reduction happening. Both the things are happening simultaneously. That's why the reaction is having a name, redox reaction. So this is the background. Somewhere electronic concept is there, and as I already said, 1 mole of electron is 96500 coulombic charge. Here chemistry and physics are coming together, making a subject electrochemistry. So let us have the first part of the topic, electrolysis. Here what we require is electrolytic cell, the container having the electrolyte, one electrode, other electrode connected together, very important thing, by power supply, DC volts. This is a positive terminal connected here, negative terminal connected here. Here anions will go, oppositely charged ions will go in, anions will go, so it is called anode. Here cations will go, so it is called cathode. So what we can say here, in electrolysis, anode is positively charged, cathode is negatively charged. External power supply given of DC potential, this is the power supply given. there are 2 electrodes, there are ions produced because of dissociation of electrolyte. Cations will be going towards cathode, making a reduction reaction. Anions will be going toward anode, making oxidation reaction. So reaction happening at anode, oxidation, and reaction happening at cathode, reduction. These reactions are not spontaneous, but they are the non-spontaneous reactions carried out at 2 different places simultaneously in a cell called electrolysis cell. So this is our main concept of electrolysis. Now regarding that, question should come in our mind where it is really applied. In real life, there are several examples of electrolysis. A simple example I can quote, and that is known to everybody, and it is the plating of gold, silver, chrome on a normal metal. Electroplating is nothing but application of electrolysis. Of course, electrolysis is carried out for many organic products also. Some other advanced electrolysis applications are also there in our further discussion of surface chemistry, but concept remains same. Apply DC potential, DC supply of certain volts to carry out non-spontaneous redox reaction at 2 different places. The electrodes are conductors, they are metals. Now this electrode can be inert electrode or active electrode, and that part we are going to learn in the calculation. It can be inert electrode, that means electrode having no involvement in the reaction. It can be active electrode even, electrode having involvement in the reaction. Electrolyte, whichever we take in the solution form, should have some concentration. That part will also come in our calculation part. Cathode should have polarity negative. Anode should have polarity positive when it is electrolysis.